Our next presenter is Dr. Katherine Hayhoe. Katherine Hayhoe is an accomplished atmospheric scientist who studies climate change and why it matters to us here and now. She is also a remarkable communicator. In 2014, she was recognized by Time magazine as one of the top 100 most influential people in the world and by Foreign Policy as one of the top 100 global thinkers. Her work was featured on the Emmy Award-winning documentary series, The Years of Living Dangerously, and she won the American Geophysical Union's Award for Climate Communication. She was a lead author for the second and third National Climate Assessments and has served on the panels for the National Academy of Science, the American Association for the Advancement of Science, and many other professional organizations devoted to understanding and communicating climate change. Katherine is currently an associate professor and directs the Climate Science Center at Texas Tech University. She has a BS in physics from the University of Toronto and an MS and PhD in atmospheric science from the University of Illinois. Dr. Katherine Hayhoe.
Thank you for that introduction, Peter, and I apologize for all those really long words. At this time in the afternoon, it's kind of best to stick with shorter words, isn't it? So I'm here to talk with you about water, no surprise. And I imagine that a lot of what I'm going to say has already been touched on by almost every single speaker you've seen today, which is great, because that's the way we get things stuck in our heads. So if we look at our rainfall, for example, here in Texas, we know our rainfall is extremely variable. In spring, we can get anywhere between 2.5 inches all spring, up to the most we've seen so far in the last 100 years has been 16.5 inches. And we've set both of those records in the past 5 years. If we look back using pollen data and other historical data, we can look back almost 1,000 years in the Great Plains. And what we see is the pattern that we have had over the last 100 years is pretty much the same pattern that we've seen over the last 1,000 years. Wet, dry, wet, dry, wet, dry. So if we do the math for Texas, I promise you this is the only math we're going to do. If we do the math for Texas, we know that we already face a significant challenge here in Texas. We live, most of us, especially here in West Texas, we live in a semi-arid climate, also known as cold desert, depending on what classification you use. And we know that our rainfall is extremely variable, and that poses a challenge to us as humans. What we like is we like nice, steady, consistent conditions, because that allows us to plan from year to year. Of course, what you want is not necessarily what you get, and instead we get something that looks more like this. This challenge is exacerbated, though, by the fact that we've been getting a lot of our water from our aquifers. And our aquifers are going down quickly. They're not being replenished at the same time scale that we're taking the water out of them, especially for the Ogallala. Other ones in southern Texas replenish faster. So if we add another factor to our equation, it's the human factor. We have competing demands for our water. Everybody wants a piece of the pie. The number of people asking for a piece of the pie are increasing. Our long-term resources in terms of our aquifer supply are going down just at a time when we need more and more. This already adds up to a challenge like we saw 2 years ago. This is the drought map for Texas back in September 2014. Do you remember that? It didn't look so good. From 2011 until 2014, the conditions we saw around the state looked like this. Our reservoirs often looked like this. It seemed like you couldn't open the newspaper without a new picture of a reservoir with a little puddle in the bottom and some cracked mud. We had record-breaking fires. This is the Possum Kingdom fire. We had a place that was 200 yards from being taken out by the second fires there. And this is our Texas Tech Stadium during the famous Haboob. Anybody remember that one? a couple years ago in October. It was bad. It was a wall of dirt. I remember it not because I was here. I wasn't here. I had my flight. I had a flight to Denver that morning. It had been rescheduled for 2 hours earlier. Don't you hate that? And so they had called me at 4 in the morning and told me to get to the airport in an hour. So I had raced to the airport at full speed. I had opened my car window to get my parking ticket, and I forgot to shut it. So I was in Denver when the haboob came through, and my car was sitting in the parking lot at Lubbock Airport with the window open facing west. Let's just say this, the ventilation system in my car still squeaks like it has a cricket stuck in it. But then came the rains. This is another picture of our stadium, and it flooded. This is a picture of the Marcia Sharp Freeway. These are the students' cars floating away. By May last year, we were pretty much entirely out of drought. And as a result, we've had really good crop yields, it looks like, so far this year, though I know they're still doing the final count. But if you look at the latest drought map, we've still got some parts of Texas, especially the east, in a minor drought. And that's part of life in Texas. What's coming up? I know you've already talked a little bit about this today. If you look at our long-term forecast for spring, it looks like we're still going to continue to benefit from El Nino. That's a good thing. But by the time we get to summer, we expect El Nino's effects to be gone. We're in a big El Nino right now. In fact, we're in the biggest El Nino. El Nino is characterized by this warm tongue of ocean water off the coast of Peru. We're in an El Nino that's the biggest we've seen since 1998. These are the El Nino events. The big orange spikes are the El Ninos, and the blue are the La Ninas. So we're still benefiting from it, but by summer, we expect it to be gone. This is how we expect the El Nino index to be changing. Now, anything in the gray area there is neutral, so we expect to be in neutral by summer. But it looks like something else is almost here. That would be a potential La Nina again, and it feels like we just got out of the last one. Now, does La Nina mean drought? It doesn't necessarily mean drought. To get a big drought here, we have to have a La Nina, which is cool Pacific temperatures, but they have to be combined with warm Atlantic temperatures. And right now, we are in a warm Atlantic phase. That's that red area here. But will we stay in it or not? If we stay in it, yes, we're looking at drought again. If we don't stay in it, it's not going to be so bad. So by summer, we expect to be in neutral conditions, but by next winter, and again, these are long-range forecasts, so take them with a grain of salt, by next winter, it's looking like we're going to see a return of our dry conditions. So if you go pretty much anywhere else in the country, you know that people are used to seeing warm and cold conditions. People are used to seeing wet and dry conditions. But we live here in Texas, and our climate's more like this, isn't it? That's part of life in Texas. So if you do the math again, we have our natural factors, we have our human factors, and they already create a challenge for us, and that's why you're here today. Because of the challenge of managing water resources in a state that doesn't have enough to go around. So many people might ask at this point, why on earth is this person standing up here when I've just heard she's from a climate science center and she studies climate change? Why does that even matter to Texas? It matters because it exacerbates the risks that we already face today. What do I mean by that? Our society, our planning, our water management, our infrastructure design, our energy supply, is all built on an assumption that we don't often think about. It's the assumption that we can have wet and dry conditions, or again, we can have extreme heat or extreme cold, but our assumption is that over climate timescales, which is the average of 20 to 30 years, over climate timescales, it all averages out. This is the assumption on which we determine what's the wettest conditions that could happen. What is the drought of record? What building codes should we have in this part of the world? What are our average crop yields going to be, not one year or the next, but from decade to decade? And most of all, what water supply can we count on? Now, these assumptions work if climate is stable. But what happens if it isn't? What happens if it's changing? Not only that, but what happens if the variability is also changing? I drove up today from Lubbock, and many of you have probably done that drive, right? Up I-27. You know that some parts of I-27 are so straight that you could get far up the road, miles up the road, if you were driving along looking in your rearview mirror. I'm not recommending that you try it, but you could, right? It's that straight. What they call it in the Navy, as a colleague of mine in the Navy says, they call it steering by their wake, looking backwards at where you've been to make sure that you stay on the road. Does that approach work? It works quite well if the road is straight, right? But just as you get to plain view, and you're going to be able to picture exactly what I'm talking about, right? Just as you get to plain view, there's this giant curve in the road, and at the giant curve in the road are these concrete silos. Everybody's seen these. What happens if you are driving into plain view looking in your rearview mirror? Going to run off the road. Worst case scenario, going to hit those silos. In the same way, planning for a future based on what has happened to us only in the past is like driving down the road looking in the rearview mirror. It works great if the road is straight, but if it isn't straight, we're not going to end up where we want to be. So that begs the next question. For those of you counting, I have 5 questions. There's nothing worse than never knowing when someone's going to end, right? I went to a church growing up, where they would have a traveling brother who sometimes came along to give the family Bible hour, usually with no notice. And they didn't necessarily know what the schedule was. And so I still remember one week we had a traveling brother in town who was giving the family Bible hour, and he spoke for an hour. And my mom started to get a bit restless because she had the roast beef in the oven. And then he spoke for an hour and 15 minutes, and she started to get really fidgety. And then he was on an hour and a half, and you could see she was starting to panic. She was wondering if she should just make a run for the parking lot. And then he started to wrap up, and he finished. It was about 1:35, and then he drew a deep breath, and he said, "And now for my second point." I think we went out for lunch that day. So, question number 3. Is climate changing? That's a fair question. Now, we're not talking about weather, because weather changes every day, every hour. You go into a movie, it's 50 degrees out, you come out, it's 90, or vice versa. Anybody ever done that before here? We're talking about climate. Climate is the forest, not the trees. Climate is the long-term average over at least 20 to 30 years. So we're not talking about a cold day, because the number one question I get in the winter is, it's freezing outside. I thought you said it was getting warmer. Well, in the same way, you could also say, what do you mean the ship is sinking? My part just went up 200 feet. So we're not talking about individual days. We're not talking about, hey, this winter was kind of cold. We're talking about long-term changes, changes on the time scale that we make our planning decisions. In Texas, every single season has been warming since the 1950s. Winter is warming the fastest. Our cold spells are getting less severe. It's true that it did used to be cold here, what your grandparents told you. It is true. We're also seeing that our summer rainfall is starting to shift into spring, and at certain places around the state, extreme rainfall is getting more common. This is a study that we did for Texas looking at weather stations around reservoirs in Texas. The red dots show increasing average temperature, summer, winter temperature, and temperature of the coldest day. And if you want more information, it's in the Texas Water Journal, which is really nice and free. I love it when these journals are free. So we've looked at all of these trends, and we've seen that, yes, things are changing around Texas. They're consistent with what's happening around the United States. This is looking at the past 100 years around the United States, how temperature has changed. But you may say, hang on a second. I turned on the radio the other day and someone was saying, you know what, that global warming thing stopped. It stopped 17 years ago. So what's she talking about? Well, again, I'm not talking about 10 years, I'm not talking about 20 years, I'm talking about 30, 50, 100 years. And when we look over long time scales, we see, yeah, 1 year might be colder, 1 year might be warmer, but we're seeing that the Earth is continuing to warm and it's affecting us here in Texas. It's not just about temperature, because if the air is warmer, more water evaporates, right? We just heard about how in Austin during the drought, they were losing just as much water to evaporation as they were to use. Why is that? Because it was so hot. The hotter it gets, the more evaporation happens. When a storm comes along, it means there's more water vapor sitting up there for that storm to pick and dump. If it's above freezing, it falls as rain. If it's below freezing, what does it fall as? I know we see a little bit of that here. Snow. And if we look around the country since the 1950s, what part of the country has seen the biggest increases in these heavy events? You watch the news this winter? You watched the news last winter? Boston, New York, DC? They're getting these crazy snowstorms. And those snowstorms are stronger now than they would have been 50 or 100 years ago because there's more water vapor sitting up there for the storm to pick up and dump. We're seeing these impacts around the world. We're seeing that our hurricanes are getting stronger. They're not getting more frequent, but they're getting stronger because they get their energy from warm ocean water. And the oceans are warming. This year, I don't know if you remember Hurricane Joaquin. It went from a tropical storm to a Category 5 overnight, literally overnight. Why? Because it passed over the warmest pool of ocean water that NOAA has ever recorded. In Australia, 3 years ago, they had a heat wave so severe, that is a little picture of Australia there, they had to add a new color to their temperature map. And they've used it again since then. That's 54 degrees Celsius. 129 Fahrenheit. Our droughts are not getting more frequent. We've always had droughts, they're part of our life, but our droughts are getting stronger again because of this evaporation. So we're seeing these impacts around the world, and that begs question number, that should be 4, why? Why is this happening? We know that in the past we've seen climate change all the time. We get more energy from the sun, we get warmer, we get less, we get cooler. We have natural cycles. We know all about those here in Texas. So when we see the planet warming, we say, well, isn't it just maybe the sun? We're getting more energy from the sun. We can look at that, though. And when we look at it, this is the temperature of our planet since the 1850s. And this is the energy from the sun now. Ready? Energy from the sun was going up till the 1970s, but since the 1970s, it's been going down. And our temperature has been going up. So if we were being controlled by the sun right now, we'd be getting cooler, not warmer. Could it just be El Nino or another natural cycle? El Nino and other natural cycles are like a teeter-totter or a seesaw. They don't create heat. They don't destroy it. All they do is move it around. From north to south, from east to west, and most of all, from the atmosphere to the ocean and back again. When we have an El Nino, it's usually warmer than average, and that's part of why last year was so warm, because it was El Nino. Where did that heat come from? It came from the ocean. When we have a La Nina, it's usually a little cooler than average. Why? Because we're putting heat back into the ocean. So if our atmosphere has been warming for decades, because of an El Nino or a natural cycle, that heat would have to be coming from somewhere. It'd have to be coming from the ocean. So rather than looking at temperature now, we're going to look at the heat content of the atmosphere and the heat content of the ocean. Ready? If one's going down and one's going up, then that's what's happening. Here they are. We don't have one going up and one going down. They're both going up. And in fact, the heat content of the ocean has increased 20 times more than the heat content of the atmosphere and the land surface and ice all put together. That's why it can't be a natural cycle. It would violate conservation of energy. There's one more reason, though, that our climate has changed in the past. Anybody who has kids or grandkids knows this. Yes? Who has seen these movies more than 5 times? Yeah, a few hands, yes, exactly. So a natural question is, isn't it just getting warmer after the last ice age, right? Well, again, when we look at the data, it turns out that the warming from the last ice age has already peaked. It peaked thousands of years ago. We've been on our way down. The next event for us was another ice age. Like they were saying back in the 1970s, they're right. Not today, not tomorrow, in, a few thousand years. For geologists, that's like tomorrow. The next thing on our calendar was another ice age until something happened. And now, a study just came out this week showing that now we are warming, the planet is warming 50 times faster than it warmed after the last ice age. 50 times. Why could that be happening? Our natural suspects have an alibi. It couldn't be the sun, we'd be getting cooler. Couldn't be natural cycles because the whole planet's warming, ocean, atmosphere, land, everything. Can't be the ice ages that's caused by changes in the Earth's orbit because we should be getting another ice age, and that wouldn't be good for us either. We don't want another ice age. We like it nice and stable, just like Goldilocks porridge, right? Not too hot, not too cold, just right. So what could be happening? Well, we know that a couple hundred years ago, we had the Industrial Revolution. We also know that the Industrial Revolution was a really good thing. We would not have the quality of life today. We wouldn't have the technology. We wouldn't have the health. We wouldn't have most of what makes our lives good today if it was not for the Industrial Revolution. It was a very good thing. The Industrial Revolution, however, was built on old ways of getting energy, burning coal and gas and oil. And we know, and you can just measure it, that when you burn this stuff, it produces carbon dioxide. You can measure it coming out of the tailpipes of our cars or out of the smokestacks of factories. We can add up how much of this stuff we've been producing, and it's quite a lot. Why do we care about this stuff? You can't smell it. You can't see it. We care about it because it does something very important. Our planet has an amazing natural blanket of heat-trapping gases. This blanket is made up of water vapor and carbon dioxide, as well as methane and a few others. Why do we care about this natural blanket? It's because the sun shines down and heats the earth up. This is my very low-tech animation. And then the earth, the sun's energy goes right through these gases like a window. The earth heats up and gives off heat energy, and these little gases trap the heat energy just like a blanket on a cold winter's night. In fact, this natural blanket keeps our planet almost 60 degrees warmer than it would be otherwise. We wouldn't be here if it wasn't for this incredible natural blanket that is part of the perfect design of our planet. Well, if this is natural, then what's the problem? When I was little, I used to stay at my grandma's house, and she was afraid in the winter that we would freeze to death. So every single night, she would sneak into our room and she would put an extra blanket on us. And every single night, we would wake up saying, "Grandma, I didn't want that extra blanket, I'm sweating." That is what we're doing to our planet. By producing all of this extra carbon, 43% more now and counting, we're wrapping an extra blanket around our planet, a blanket our planet was never designed to have and it does not need. And just like an extra blanket would trap more of your body heat, that extra blanket is trapping more of our planet's body heat. And that is why we're warming today. This is something you might not know. Everything I just said, all the science I just explained, we've known for a really long time. This guy here, Fourier, who's famous in math and engineering, Fourier in the early 1800s discovered the natural blanket. This guy, Tyndall, in the mid-1800s, discovered that coal mining was putting more of these little heat-trapping gases in the atmosphere that was adding an extra blanket. We've known about this extra blanket for over 150 years. The third guy here, a Swedish chemist called Arrhenius, he calculated how much the Earth would warm if we doubled or tripled this blanket. And he was right, using physics that we knew back in 1890. That's pretty old. And then this guy, I like saying that because his name is actually Guy. This guy was a British engineer who first measured the warming of the planet back in the 1930s. Is that crazy or what? This is old stuff. We're not talking gravity waves here. It's really not even that cool or new. It's really old. Now, I know that people probably have a few more science questions, but I want to move on to talk specifically about water to end up with. So I'm going to leave you with one of my favorite resources called Skeptical Science. It answers all of our but what about questions. If you have any but what about question, I pretty much guarantee they will have an article on it there. And what I love about them is they don't just give you opinions, they link you directly to the scientific studies if you want to read the studies yourself. Why does all of this matter? We care about a changing climate because it exacerbates the risks we already face today. What risks do we already face today? Drought, that's nothing new. Flood, hurricane, extreme heat. We face all of these today. It's part of life in Texas. If you look at the number of billion-dollar weather and climate-related disasters since 1980, there is one state that has more of those than any other state, and that's us. Why is that? It's because we get everything. We get hurricanes, we get ice storms, we get blizzards, heat waves, droughts, tornadoes, derechos, hail, floods. What am I missing? Sorry? Haboobs, yes. We get it all. We are already very vulnerable, already. But in the future, we expect these vulnerabilities to increase. This is a figure from our state climatologist, John Nielsen Gammon, showing how rainfall, summer rainfall on the bottom and summer temperature on the side, are very closely related. We don't get extreme heat without drought. We don't get extreme drought without heat. They go hand in Texas. And we know that as we progress into the future, we're going to be seeing more extreme heat. On average here, we only see about a week of days over 100 degrees on average. But in 2011, it was crazy. Anybody remember their air conditioning bills in 2011? I do. It was bad. But, and this is the work we do at the Texas Tech Climate Science Center, if we continue on our current pathway, if we do, by the 2040s, the average summer could look like 2011 in terms of extreme heat. And by the 2080s, it could be a lot worse. We don't want that. The National Climate Assessment, a great resource if you're interested in more, already talks about how rising temperatures are increasing the demand for water and for energy. And this has implications for our development, for our natural resources, and for our competition. Because the pie gets smaller the hotter it gets, the pie being the amount of water. We know as we look to the future that the number of days with heavy rainfall is likely to increase, but at the same time, the number of days with dry conditions is also likely to increase. So what's happening? Our variability is getting stretched. A study that I just did this past year looked at drought conditions using the Standardized Precipitation Index. In spring and in summer, as the world warms, our risk of drought increases. Again, because evaporation increases, our heat increases. Again, in the National Climate Assessment, they're talking about how already changes in our rainfall have been observed. They're going to affect our management practices. In the Great Plains, we are particularly vulnerable to changes in water supply and demand. Our road is curving. We need to look ahead and see that curve and plan for it to make sure we end up in the right spot. Because climate change exacerbates the risks we already face. On the left here, you see changes in water withdrawals over the next several decades without any changing climate, with just a straight road. They increase across much of Texas already due to population, due to changing water demand. What happens when you overlay a changing climate? The risk increases. So climate change is not bringing strange new things we've never seen before. It's not bringing bizarre plagues of fluorescent locusts or whatever other strange thing you might be able to think of. It's bringing the same old that we've already seen before, but in many ways it's making those stronger, more frequent, tougher to cope with, just when we ourselves are growing at the same time. So what's the bottom line here? The bottom line is that we already see warmer temperatures, changing rainfall patterns, higher evaporation rates, stronger droughts, not more frequent, but stronger, and more heavy rain events. If we don't factor these changes into our planning, we're going to end up with the wrong answer. It just makes sense to take our eyes off the rearview mirror and, really for the first time in 100 years, start looking down the road ahead and say, what's happening? What can we prepare for? How could, for example, how could we be smarter with our resources? If you look at these cities, El Paso uses the least amount of water per person, followed by San Antonio in Texas. Midland, Amarillo, and Lubbock is not on this list, but I would bet that we're up there near the top. We use a ton of water per person. If we know water is going to become even more scarce in the future, it just makes sense to be smarter with it, and we can, and we know how. We can be smarter with our farming methods, using methods like no-till agriculture, drip irrigation. It saves us money, it saves us water. We know how to do these things already, and they will keep us on the road as we go around the curve. We know how to be smart with our resources. We in Texas added the most wind energy of any state in the country, and this past week, we set yet another record for the most wind energy generated. How much water does wind energy use? 0. It's a smart way to get our energy. It takes a piece out of the pie. So what is the way forward? Is the way forward to say, whoa, there's a curve in the road there. I'm not too sure I'm going to hit the brakes. I'm just going to pull over. No, we can't do that. That's not the way we live. The way forward is, number one, to build our resilience to the risks we already know exist that we face every day. We know what those are. Number two, increase our resilience to the risks that we know are getting stronger or more frequent. And number three, and this is what I'm doing with Austin Water, I'm doing it with San Antonio, I'm doing it with San Angelo and Las Cruces. We actually generate, at the Climate Science Center, we generate quantitative information on what's going to be happening to rainfall and stream flow in the future. I can't tell you if it's going to rain in 2022 on July 18. I have no idea. That's weather. But I can tell you that decade by decade, we see these trends happening. And we can look at how strong they are and where they're happening. So rather than stopping, we can move forward. We can move forward, keeping our eyes fixed on the road, making sure that when it curves and turns, we stay on that road. Because we all want a safe future. We all want to be in the same place, and I think that we can. Thank you.